Lesson 3 preview video. It's an Edpuzzle on sampling techniques. You should have already watched it. It's 4 minutes and 53 seconds. There are 10 questions. It's a 10-point minor grade. Data collection and experimental design. That is the lesson for today. Unit 1, Lesson 3, experimental design and sampling methods. The students will be able to design a statistical study. The students will be able to collect data by doing an observational study, performing an experiment, using a simulation, or using a survey. The students will be able to design an experiment. The students will be able to create a sample using random sampling, simple random sampling, stratified sampling, cluster sampling, and systematic sampling, and know how to identify a biased sample. A biased sample is in the next part of the notes, not today's notes. Designing a statistical study. First of all, identify the variable or variables of interest, the focus of the study, and the population of the study. Develop a detailed plan for collecting data. If you use a sample, make sure the sample is representative of the population. Collect the data. Number 4, describe the data using descriptive statistics techniques. Number 5, interpret the data and make decisions about the population using inferential statistics. And last of all, identify any possible errors. Types of studies. Data collection. In an observational study, the researcher observes and measures characteristics of interest of part of a population, but does not change existing conditions. There was no type of research intervention. In an experimental study, the researcher manipulates one of the variables and tries to determine how the manipulation influences other variables. The manipulation is referred to as a treatment. A quasi-experimental study uses intact groups rather than random assignment of subjects to groups. Variable types in experimental studies. The independent variable in an experimental study is the one that is being manipulated by the researcher. The independent variable is also called the explanatory variable. The resultant variable is called the dependent variable or the outcome variable. So different names for the two different terms. Groups in experimental studies. Treatment group is a group in an experimental study that has received some type of treatment. The control group is a group in an experimental study that is not given any specific treatment. In many cases, subjects, sometimes called experimental units in the control group, are given a placebo, which is a harmless, unmedicated treatment that is made to look like the real treatment. Data collection methods. A census is a count or measure of an entire population. Taking a census provides complete information, but it is often costly and difficult to perform. Simulation. A simulation is the use of a mathematical or physical model to reproduce the conditions of a situation or process. Collecting data often involves the use of computers. Simulations allow you to study situations that are impractical or even dangerous to create in real life. Often they save money and time. There's a lot of simulation used like when a hurricane is coming towards an area so they can kind of track what's going to be happening. Data collection methods survey. A survey is an investigation of one or more characteristics of a population. Most often, surveys are carried out on people by asking them questions. The most common types of surveys are done by interview, mail, telephone, or internet. Deciding methods of data sampling. Example 1. Consider the following statistical studies. Which method of data collection would you use to collect each study? Explain your answer. So, a study on the effect of changing flight patterns on the number of airplane accidents. Probably going to use a simulation for this. So use a simulation because it is impractical or dangerous to create this situation. Airplane accidents, when it want to cause them for a study. Same request, different situation. A study of the effect of eating oatmeal on lowering blood pressure. This is going to be an experiment. In this study, you want to measure the effects of a treatment, eating oatmeal, has on patients. You would want to perform an experiment. Number 3, different situation. A study of how 4th grade students solve a puzzle. That would be observational. Use an observational study because you want to observe and measure certain characteristics of part of a population. Different situation, a study of U.S. residents' approval ratings of the U.S. president. You could use a survey that asks, do you approve of the way the president is handling his job? Experimental design. Hawthorne effect. An effect on an outcome variable caused by the fact that the subjects in the study know that they are participating in a study. Let's say you are in a study and they're investigating the results you might get from a new diet supplement. The fact that the subjects would know that they're in a study about that may change other things as well, like they might eat better, exercise more, and thus the results aren't necessarily coming from what they were looking at. A confounding variable occurs when an experimenter cannot tell the difference between the effects of different factors on the variable. This is going to come into play with what I was explaining a minute ago. Placebo effect occurs when a subject reacts favorably to a placebo when in fact the subject has not been given medicated treatment at all. Experimental design, blinding. Blinding is a technique where the subjects do not know whether they are receiving a treatment or a placebo. When my oldest daughter was born, the doctor offered us to participate in a formula study. Young teacher, free formula for a year, why not? We didn't know they were testing a new fat source. We didn't know if we had the regular formula or this new formula. So that was a blinding technique. In a double-blind experiment, neither the experimenter nor the subjects know if the subjects are receiving a treatment or a placebo. So if the doctor also didn't know which group we were in, that would be a double-blind experiment. Experimental design randomization. Randomization is a process of randomly assigning subjects to different treatment groups. In a completely randomized design, subjects are assigned to different groups through random selection. Blocking. In some experiments, it may be necessary for the experimenter to use blocks, which are groups of subjects with similar characteristics. In this situation, for a randomized block, all subjects would be broken into groups based on age. In that diagram, there's one group that's 30 to 39, another 40 to 49, and then 50 and over. And from each of those groups, you have a control and a treatment group. Experimental design, matched pair design. In a matched pairs design, subjects are paired up according to a similarity. One subject in the pair is randomly selected to receive one treatment while the other subject retreats a different treatment. Matched pair design uses quite often sets of twins, and they would be very similar. So they make a good pair up. Randomly, one will get one treatment and the other would get another treatment. Samples and sampling. Sample size is the number of subjects in an experiment. Replication is the repetition of an experiment under the same or similar conditions. Sampling techniques are used when part of a population is to be surveyed. The sample that represents the whole population is called unbiased. A sample that does not represent the whole population is called biased. Some type of systematic error has been made in the selection of the subjects, and we'll be dealing more with unbiased and biased in the next lesson. Using samples saves time and money. Sampling error is the difference between the results of a sample and those of the population. Sampling techniques, random sampling. Random sampling is used to see that all the possible elements of the population have an equal opportunity of being selected. Random samples are selected by using chance methods or random numbers. A simple random sample is a sample in which every possible sample of the same size has the same chance of being selected. Now for an example. There are 615 students currently enrolled in a statistics course at your school. You wish to form a sample of 9 students to answer some survey questions. You use the random numbers table to select the students who belong in the simple random sample. So there is part of table 1, random numbers. In the box at the right, the directions say use the third row of random numbers to create our list. So we want 9 different student numbers. So I have 9 blanks down at the bottom. And the row that is outlined in blue is where we're going to get our numbers. We are looking for numbers between 1 and 615 because there's only 615 students. So if they were randomly given a number, the highest it would go is 615. But it's 3-digit numbers, so we're going to break that row into 3-digit numbers. So there's our first break, and that number is 596. It is 615 or lower, so that's going to count as our first randomly selected student. Break off the next 3. That's 547, and that works too. So that is our second one. 3 more digits gives us 196. That works. It's our third value. Third student number that we selected. That works. Next 3 digits are 627. That's too high. We only have 615 students, so we have to cross that one off. Break off the next 3 digits. That's 386. That works. So that's number 4. Break off the next 3. You get 500. That works as well. Break off the next 3. That is 040. So it's technically 40, but we're going to write it as 040 because it's a 3-digit number, but it's actually only the 40th person. Breaking off 3 more numbers, that's 535. That works. It's 615 or less. That's number 7. Break it off again. We get 894. Too big. So cross that one off. Do your next break, 031. So that's 31. That works. And if we do our next break, we get 292, which also works. And that is the 9 numbers that we would select for the students that we would interview in this situation. Systematic sampling. Systematic sampling numbers the population and then selects numbers at a regular interval. Let's randomly figure that out. Let's see. We're going to do every third one. To use systematic sampling, the population must be randomly mixed before they're numbered, and the first subject would be selected at random. So let's roll the die again, and we're starting with number 2. So that is the first house that we would be interviewing, and then every third. So 3 more, 3 more, and those would be the homes included in the sample. Stratified sampling divides the population into subgroups called strata according to some characteristic that's important to the study. A random sample is then selected from each group. For example, to collect a stratified sample of the number of people who live in West Ridge County households, you could divide the households into socioeconomic levels and then randomly select households from each level. So we're breaking it up. One group is low income, then middle income, high income. So those were divided based on socioeconomic levels, and then they took a random sample from each one. That is stratified sampling. Cluster sampling uses intact groups called clusters. When the population falls into naturally occurring subgroups, each having a similar characteristic, a cluster sample may be the most appropriate. To select a cluster sample, divide the population into groups called clusters, and then select all the members in one or more, but not all of the clusters. For example, to collect a cluster sample of the number of people who live in West Ridge County households, divide the household into groups according to zip code. Then select all the households in one or more, but not all, zip codes, and count the number of people living in each household. So there is a map of West Ridge County and zip code zones. Randomly select one and interview all of them in that particular zone. Sampling techniques, convenience sampling. Convenience sampling consists only of available members of the population. It uses subjects that are convenient. This often leads to biased studies and is not recommended. Let's do example 4. You're doing a study to determine the opinions of students at your school regarding stem cell research. Identify the sampling technique you are using if you select the samples listed. Discuss potential sources of bias, if any. So part A, you divide the student population with respect to majors and randomly select and question some students in each major. Since students were divided into strata by major and a sample is selected from each major, this is stratified sample. Sampling techniques. Example 4, part B. So same situation, different sampling technique. You assign each student a number and generate random numbers. You then question each student whose number is randomly selected. This is simple random sample since each student has an equal chance of being selected. see. You select students who are in your biology class. Now remember, we are doing a study to determine the opinions of students regarding stem cell research. And if you are just selecting students in your biology class, that's a convenience sample. And the sample may be biased because biology students may be more familiar with stem cell research than other students and may have stronger opinions. And here are the assignments for today. The classwork assignment, working with a partner, 5-point minor grade, and a quizzes for the lesson. 11 questions, 10-point minor grade based on your percentage.